Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind, doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30pm local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night. And welcome to our Wednesday Experimenters Night. And we've got a huge program on tonight. And I've got Matt in the, Matt VK7MAT in the green room on the waiting there. I'll just transition across. Say hello to Matt.
Mate, thanks for having me on.
Excellent. So we'll just do acknowledgement of country. So I wish to acknowledge Tasmanian Aboriginal people as the traditional owners upon this land where we're presenting today, and pay my respects to elders past, present and emerging, for they hold the memory, the knowledge, the culture and hopes of Aboriginal Tasmania. So we've got on the stream, we've got all sorts of people. We've got Darren from up in Mount Isa. Hello Darren, and good to catch up at QTech. We've got John Hall, we've got Bronson, we've got Lisa, we've got Ken over in New Zealand. Actually, that's a good point. I don't know where Andy is. Andy, our UK correspondent, it's not on tonight. We've got Ron, we've got Richard. Hello, Richard. We've got Don, VK7YXX, and we've got David, VK7DBX. So welcome, and please, drop your questions into the chat as we're going through. So I have Matt VK7MAT in the green room, and I've got I'll switch across so you're on screen now, Matt. Now the reason I've got Matt along is Matt did a fantastic description of his field day experience in our Discord channel, and I thought, this is excellent. This is the good, the bad, and the ugly of operating on a field day, preparing for a field day, operating on a field day, and then working your way through. So, what I then asked Matt whether he would be prepared to do a bit of a presentation on his experience, and he's come up with a fantastic PowerPoint presentation, which he's going to take us through. So, with no further ado, across to you, Matt. Over to you.
Thanks very much, mate. Thanks for having me on tonight. So I take the opportunity to share some of the good and the bad from my field day experience. Probably a little more bad than is good, but that's all right.
Learning, opportunity.
Learning, yes. I'll share my screen.
Pedal faster. Oh, there we go. There we
Awesome,
go.
cool. All right.
Cool.
So I'll kick off. So I went to the Dazzler range. So this is based in northern VK7, so about 16 kilometres inland from the coast there. Now, normally go to Mount Horror, which is based in the northeast, but I had some access issues, which I won't talk about online, so I had to make a bit of change.
Okay.
So this happened about 2 weeks out from the event, so not ideal, but anyway, I made the decision to head up there. So you see here, it's just a repeater site here. It's quite a big repeater, which I'll talk about a bit more in depth in a minute. Yeah, it's got a fantastic setup area around the repeater. And that red dot is where I set my gear up there.
And from that location, you can see 360 degrees. Is that?
Yeah, you can. So north, northwest, northeast, you can see.
Okay.
Not so good heading back south, but yeah, definitely.
Okay.
The picture here on the left-hand side is looking northwest. You can see Port Sorrel and a couple of towns down there.
Fantastic. Okay.
This site is used as a fire tower, so there's a fire spotting tower there.
Okay.
It's currently not manned. It's got, you can see here, it's got the AI camera, which was obviously spoken about in a stream not long ago with Reast, so that you can hear them move around. So I think they only man that during the busy periods.
Okay. And those solar panels, I assume, are TAS GRN, are they?
Yeah, I believe they are. Yeah, quite
Yeah.
large.
Okay.
So talking about the repeater site, it has 107 listed assignments on the site, and they range from 52 meg up to 19.4 gig. So it has a lot of assignments on the site. I'm not sure that's common for most repeater sites around Tassie, but yeah, it's quite busy. A lot of GRN-based comms come from that site, so it covers most of the north of the state.
Okay.
That's the government radio network operated from that. There's a paging network repeater on the site. Yes, the operates on about 148.7, and I was having a big concern. It was generating a lot of QRM during the event. You could see it come up on the waterfall, and you could hear it at times. Poxag's got that really distinct sound. You could hear it come through the radio occasionally. It was ranging from the go to S8, S9, and then back to S1, so it would wipe out any comms. It would happen sporadically heaps, and then you wouldn't have it for a while. So it'd be pretty consistent. I think Tassie probably shoots off about 500 odd page messages a day, so it'd be consistent with that.
Okay.
Lots of trail bike riders come to this site, so there's lots of tracks, and they come up and check out the fire tower. So I had lots of good conversations with trail bike riders that came up. One of them spied a bottle of water I had beside me. Said, "Oh, can I have a drink of your water?" So I had to. I said, "I'll have it. I'll give you one from the car."
Yeah,
I like drinking that. Yeah. And it has a really good pad around the site, but the dust is very, very dusty on the site. It's something to be more mindful of.
Oh, okay.
Moving to antennas, I ran antenna for 2 metres, 70 centimetres, 23 centimetres, and 6 metres.
Okay.
10 element Yagi for 2, 15 element for 70, 18 elements for 23, and I ran a tri-band vertical for 6 metres, which I'll talk about a bit why I made that decision. I ran a preamp on the 70 centimetre antenna, and I ran LMR 400, and I ran the LMR to 200 for the patch leads out of the preamp. And it's just a bit of a splat map based on the antennas I had and the power that I was running, so that's heading directly towards VK3.
Okay.
And 6 metres and 23 centimetres. So one of the issues I had, and I'm more than happy to admit the issues I had, was the learning experience myself when I was out there, so drop some comments if you had something similar or have some suggestions for me to improve. I'd recently brought the 23 centimetre antenna. I hadn't put it up, got down to site, put on my mast, went to put the antenna up and realised that the antenna clamp was too big for the diameter of the clamp of the antenna mast. Went, that's a bit of a problem. So I had a bit of a look, and I happened to have a drill with me, and I had a brand new antenna clamp in my box. So I ended up drilling a new hole in the antenna, which allowed me to put that smaller mast clamp in. So I got away with that, which is very, very lucky. Yep, and that's probably one of the things there. The point of the list is, you think you're taking too many tools, you're probably not, because they're going to get used. So yeah, it's lucky I had that. One of my other disasters from the event, I planned to make a Moxan antenna for 6 metres. I'd watched some guy on YouTube, I think it was Ham Radio DX or something like that, some random guy, got the idea from him. ran the calculator, built the antenna, finished it a couple of nights before field day, put it up outside about 10 o'clock at night, ran the sweep over it, and it went very, very high. So I had a bit of a play with it. I'd planned to have it about 50.150, and it went into this, I think it went about 61. So double checked my measurements, they were as per the calculator. So I'm not sure what's gone wrong there, so I have to play with that. So anyway, I scratched that off the plan and I jumped up my mast and pulled down my vertical. So that's why I ended up with the vertical tri-bander instead. So it's a little bit disappointing I couldn't take that down and use that. So that will go on the to-do list to fix that one. So anyone's got any suggestions why that's gone wrong? It's built with 12mm alley tubing, but I did use 10mm for the corners, the bending, so I'm not sure if that's had an impact or not. So the radios that I used ran the IC 9700. That was for two 70 and 23, and I ran the IC 7300 for 6 meters. Ran the Yaesu G450 rotator, just a generic HP laptop. I ran the Heil Pro Set Elite headphones. First time I've used them. I had them here for a while, but I haven't got them out of the box. So I used them for the weekend. They were really, really good. And I just had the Qsheng UVK5 just to listen to the repapator and stuff that was close by. And I always take the Garmin InReach with me. I wasn't quite sure what phone reception would be like up there on the site. So I had that there with just in case something went wrong. That's a setup. So I just ran a 3x3 meter gazebo. I slept the night there because I did the 24-hour event. So I just set the swag up in the back of the gazebo and slept there. I think I went to bed about 11 o'clock and was up again by about 7 o'clock next morning because there wasn't much activity on the bands at the time. So it was on and off. So as the night got on, got fairly windy. I was a little bit concerned at times I hadn't pegged the gazebo down enough, but it managed to get through. So yeah, and it was windy the next morning. Then it plateaued off during the next day. Now, I found out there's a very big generator up there with the repeater site, so that was a lovely hum during the night to sleep to as well. So one of the things I added in previous field days, I've just ran a mast into a home-built holder. It's one I drive my car up to, and one of my failures from the last field day was I was up on Mount Horror. I was in and out of the car 1,500 times with the antenna. Finished at 8 o'clock that night, went to start my car, and it was flat. Yes, so I had to ring one of my mates that travelled an hour and a half to jumpstart my car. So, yeah. So this time I've implemented a rotator with my setup. I just basically built a metal frame, and this is designed to fit into the back of my ute. So the ute has the wheel arches. So this is about 950 by 950. This is being built there. I've ran plywood for the base and the top plates, and I'll change that to metal a bit later on. And one of the things I didn't think about when I was building the base plate for the rotator, I see the picture here on the right-hand side. I've got the plug facing out to the corner, which faces directly to one of the uprights of the steelwork. And I was lucky that the actual plug fitted between the steel and the rotator. So that was a bit of a concern. I was thinking I'm going to have to recut that, but I got away with it. So band conditions, I'd say they were pretty atrocious for the whole field day event. Reading a lot of the soapbox comments that have been posted, a lot of people have experienced the same thing. So just having a look at the Hepburn charts here from Saturday and the Sunday, there's a very big void between VK7 and the rest of Australia there. Lots of black, which, I don't think compared to other field days, transmissions from VK3 and elsewhere in Australia, it was very, very quiet. I've never really heard of that quiet before. So, So contacts and score. Longest contact I had was in the 6 meters SSB. It was 1,648 kilometres, and that was with a VK4 station. And that came through at about 9:30 at night. I was actually out on the phone, and I heard the radio go off, and it was a cracking signal. It was a genuine 5.9. So I answered that CQ call as a couple of VK2s, but they moved off the band really quickly. I think I posted on Discord saying, 6 meters is about to open, and it lasted for probably 3 minutes, and then it was gone, and that was it. Yep. So it's quick, so it disappeared really quickly. So that was a little bit disappointing. Contacts of VK3 only had a few this time. They ranged between 322 to 466 kilometres between. The VK7 contacts, they all range between 29 to 72 kilometres. They're all fairly close. Didn't make any down south. They were all back to Launceston in the northwest. Numbers had 12 contacts on 6, 20 on 2, 14 on 70, and I had 12 on 23. So 58 QSOs in total, and a score of it was just under 10,000, so relatively low score. Compared to last build day, I was about 12,000 points down compared to what I was last time. So yes, they are. Yep. So predominantly back with the guys that set up on Mount Barrow. That was VK7, Delta Whiskey, and PD. Yep. Yep. And back to Northwest was Eric and VK7 HP. So they were the main ones for those. Yeah. And this is the chart. That's the direct chart out of VKCL. Just having a look at the big quiet period here. So say from 5 o'clock that afternoon, it was very, very quiet up until about 10 o'clock the next day with the odd contact here and there. So I chose to stay around. Given the broadcast was around 9:30, 10 o'clock, I thought I might pick up some contacts after the broadcast, which I did. So there's that little spike of contacts there towards the end. This is the contest radar, so a lot of people post up where they're operating from. So it's just a bit of a map. Not everyone posts on this, so but it's a good idea, the stations that were around. For me, I predominantly been between about azimuth is about 330 to 30, so yeah, normally beam into VK3, and I pick up the other contacts off the side or the back of the beam back into VK7, and just spun the beam around if I was doing 23. So the good and the bad things, my prep time was atrocious this time. I've just recently upgraded my license, and my concentration was to study for that, and that was about 2 weeks prior to field day. So after I sat my exam, I got on to building all my stuff. So a lot of that, the rotator frame I built, started at about 2 weeks out. So this time I planned the prep a lot earlier. I was late leaving town. Someone couldn't find the walls to the gazebos. Had to do a quick dash down to Bunnings to buy some more. I had 2, but I really wanted 4, so I did a quick dash down to Bunnings, and I didn't get down to Dazzler to about 11:30. And I didn't get on the air till about 1300, so which is a bit disappointing. Missed that first hour. Spoke about the antenna clamp was being too big. The mast, I run a dodgy J car 2-piece mast, and it wouldn't. The second part of the mast wouldn't elevate at all, so I can only get the top section up. So antennas weren't high as usual. The Mox on, spoke about that being a big fail. Lots of late nights up to the lead up to the event. So I spent the morning before I was up building patch leads at about 3 a.m. in the morning, which I hadn't got done. So lots of late nights, and the QRM from the paging network. Some of the good things I had my first contacts on 23 centimeters. So I just mentioned I'd recently upgraded my license. That's my first time using 23. So I had my first contact with the VK7 Delta Whiskey. And obviously all the other contacts. The rotator worked really well, so I was really pleased with that. And it was good for trying to pick up the signals in VK3. If they're a little bit weak, you could rotate around to try and make it a bit stronger. I was fairly happy with the site setup. I'll probably set up very similar again. I initially planned to have the rotator in the back of the ute, but I had the trailer. I thought, I'll try it on the trailer, and I threw on that, and that worked quite well. And I could lock stuff or gear away in the back of the ute. And I made a really concerted effort this time to ask operators if they had other bands. In previous times, I've spoke to them I've made contact on 2 meters, and then I just let them go. So I made the effort to ask them, have you got 70, 23? So I picked up some extra contacts that way. It was great. It was good being out. I always love being out in the field, so it was good to be out and about.
We've just got a few. I've asked for questions. Mm-hmm. Just a comment, really. Solar panels in the windscreen attached to the battery would stop a flat battery. But I think you know that.
Yes. I've learned that. I run a Honda 2 kVA generator, and that actually has a charging kit for cars. And that was sitting at home here in the junk room. So I've learned that lesson.
So it wouldn't have helped anyway.
I've also got a jump start pack, and guess where that was? At home as well.
Ah, righto. Okay,
Yes.
that's not good. And I was sort of thinking about Mount Horror. You don't really have like if you were up the top near where all of the equipment is, not down where the lookout is. You could sort of do a bit of a jump start down the hill, but the hill from where the lookout is not that great.
No. You want to make sure you've got the start first go.
Well and truly, because then you're in the swamp bit of Mount Horror, which is not good. Anyway,
all bad. So some things I'll be doing for summer field day, which I'm going to start doing very soon. Start my prep a lot earlier. I also need to get a new mast. Do you know where I could get a new mast from at all?
oh, have we got a deal for you? We have 8.1 metre masts still available here on sale for $40.77. So cheap at half the price.
Very nice. So I might have to invest in one of those. So I was need to upgrade mine. I'll build some preamps for 2.6 and 23. They've been on my cards for a while because I obviously run some satellite stuff at home, so I'll be able to use those for that. 6 metre antenna. I'll try and fix the mocks on, but I'll probably move the building a Yagi if I can. That's the DG7 YBN design. I'll probably go for that. Not sure how many elements yet, but I'll probably go for the Yagi over the mocks on. Filters, they would be probably really handy this time with the QRM from the pages, so I'll definitely invest in some of those. And run a vertical for the local FM contacts. I spent most of the time hanging around on SSB, and I found I probably missed a lot of the local contacts, so I'll probably take another radio with me and run a vertical for those.
Yeah, that's probably a great idea, and a tri-band vertical or something like that would be, it means you don't miss any of that. So yeah, there's quite a few people here who run FM and FM on verticals and SSB on Yagis. And probably Matt, a comment. I when I run 6 meters, I run a 4-element Yagi, which I think actually is a DG7 YBN design.
Mm-hmm.
And that's the only Yagi that I fully take apart because of its size. The other ones just go on the roof and all sorts of stuff. But that particular one, the width of the elements is about the length of the boom, so it all gets taken apart and strapped together.
Yeah, so that'll be my plans for summer field day. So yeah, they'll probably change that out. I'll find other things to do between now and then. But yeah.
Oh no, fantastic. That is absolutely fantastic. Now, just having a look. Any suggestions about field day for someone new to the hobby? Comes from Lisa.
My biggest advice is just get out and have a go. I think you don't need a lot of gear to get out field day, especially the VHF UHF one. You don't need a lot of gear. So I think Lisa's based down south, isn't she? So there's lots of generally lots of people out about in and around Hobart that participate in field day, so I highly recommend. Don't necessarily have to go out for it. You can do it from home. You have the option of going out portable or doing it from home. There's 2 categories. So advice, just get out and have a go. You'll get lots of support from members in the club and other people out and about during field day. So it's fairly it's a very pleasant atmosphere compared to probably some other contests, let's say.
Oh, well and truly. The only one that's probably friendlier is the Remembrance Day, but that's a HF, VHF, and everything contest. So yeah. But great suggestion. Try it from home. So be a home station and see how you go, and then think about how you translate that into a field day or a portable mobile arrangement. And can I just do a plug? We're doing equine endurance on the weekend, which is a fantastic test for your mobile and portable setup. So just a bit of a plug there for equine endurance. So any final comments, Matt? And please, those people who are online, please drop your questions into the chat, and I'll forward them on.
And also, if you want to contact me direct, just go via my QRZ page. You want to drop me an email, I'm more than happy to answer any questions that way as well. But definitely drop them down on the chat.
Oh, hang on. We've lost you, Matt. We've lost you. Just say something.
Still here hiding.
Oh no, you're still here. Oh,
Yep.
yeah, we just lost you. Oh, sorry. I'm looking at the stream. The streams. The stream, which is 30 seconds behind. No. Just ignore me. So now Matt also has a fantastic Instagram page. You want to do a bit of a plug for your Instagram page?
Yes, so Instagram page is the RF Reast. I just post probably a very photo focus out there in parks. I post a lot of content around parks on there. And then else I'm up to, so we'll see some posts come up about field day over the next few weeks. And then I run out of content. I need to go back out and do some stuff to take more photos with. And I definitely check that out and drop comments. That'd be great.
Fantastic. Now I'm just doing a bit of a manual mute here because we had a bit of echo. So I'm manually muting myself, Matt. So just, but any final comments? Any final comments?
No, none for me, mate. Thank you very much for having me on. It's great to be able to share experiences and hope people learn from my mistakes. I definitely learn from mine, and I think that's the best thing about amateur radio. It's something there's always something to learn and improve on. I guess you're always trying to chase the best.
I know, well and truly. And can I just say Tasmania is probably the place for field day. There's plenty of hills and mountains and whatever else that you can get up actually onto, and point your antennas in all sorts of directions. So that is absolutely fantastic. So thank you very much, Matt, and good luck. And you can go and have dinner now.
All right, mate, thank you very much.
Cheers. Now let me go to. Okay, fantastic. All right, Matt. We'll catch you later. Okay. So this is VK7 OTC, the club station of the Radio and Electronics Association. I'll just make sure that I'm not muted. I'm not. So and fantastic for Matt is relatively new to the hobby. Has some great skills to be able to fabricate things and do all sorts of things. And so I thought getting him on and showing in a relatively short period of time how he has been able to actually get on air. He has only had his upgraded license for, I think, 2 or 3 weeks. So he's grabbed the bull by the horns and built all this stuff and gone portable and made mistakes and learnt from them, and you can expect a fantastic score from Matt, I suspect, in the summer field day. And the summer field day is traditionally much better. The conditions from a VHF and above point of view are exceptional, and long distance contacts on VHF and above well and truly possible. So there you go. Now, okay, the next thing that we have tonight is I was going to show you a little bit of I've got the edge of my magazine that has gone off. Now, continuing on the VHF and UHF and above theme, DUBUS magazine. Now, DUBUS magazine is if you're really into VHF and above, DUBUS magazine is the magazine right at the moment. CQ VHF and a few of the others don't exist anymore. DUBUS comes out of Germany. It is a bilingual magazine, so all the articles are both in English and German. It comes out quarterly. It's relatively cheap, and it gets delivered directly to you from Germany. And they put together the Technics magazines each year as well, which takes a selection of the articles that appear in DUBUS and put them into a Technics magazine, which they then publish at the end of the year. Now, there is some fascinating articles in here, and the very first one, and this one will appeal to Lisa, I suspect, who is on. And Matt's on the chat, so fantastic. Now, Joachim Koppen, who is DF3GJ, who is actually from the team that maintains the beacon, the 10 gig beacon, has a fantastic article about finding your antenna's position by the Milky Way. So this is all about focusing in on the hydrogen line on particular areas within the Milky Way, and recording the noise, and measuring and recording the noise from those particular noise sources at the 1420.4 megahertz frequency. And so he goes into how you actually do this, Milky Way basics, the method, how to proceed. There's some signal peaks here that you can see. The waterfall of the spectra recorded over the 24 hours as the Milky Way goes past, and focusing in on then measuring that and optimizing your noise level for the particular arrangement that you have. And so all of the elements of and Richard's on here as well. We well and truly have we've been taught by the maestro, as in Rex VK7MO, about optimizing every element of your in our case 10 gig Earth Moon Earth arrangement, and being able to optimize every element of it so that you have the maximum amount of moon and sun noise before you even start to try listening for a beacon and all of this sort of stuff. So this is what Joachim goes through in this particular article, and just to show you, the article is then repeated in German so you can brush up on your German. There is a fantastic article by Paul Wade, W1G8Z, who's a bit of a legend in microwave circles. He has come up with all sorts of designs. In fact, I'm using his sun noise detector, his design for sun noise on the 10 gig system. So he's come up with a gas FET low noise amplifier bias, the simple, cheap and full resistant circuit. Now, biasing gas FETs is a bit of an art, and gas FETs are used because they are very low noise devices for low noise amplifiers, but you need to be able to bias them quite accurately, and if you get the biasing wrong, you have the ability to let the smoke out of the device. So this is all about Paul Wade telling you about a circuit for a simple, cheap and full resistant circuit. Now, the next article, interesting one, RG213 coaxial chokes for Yagis, HF utility versus VHF constraints. So this is all about taming common mode currents. And you can see here's an air-wound choke, coaxial choke. And he goes through and he has a calculator that you can put in the parameters and calculate what you need for to create an RF choke. It's a choke balun calculator. By Justin Johnson, G0KSC, who's a regular contributor in DUBUS, and also this is quite interesting. He goes into the heat conversion in coaxial chokes, and you can see here's an infrared picture of an air wound choke using RG213. And the chokes, they convert the RF energy into heat, obviously, and in this particular case you can see that particular choke is actually quite quite hot. Now what? Oh, now waveguide transitions. That's now RA3AQ. Now we've gone up in frequency here, 47 to 76 gig. Rectangular to circular waveguide transitions for these particular frequencies, and so this is all about the design, the modelling and simulation, and the design of waveguide transitions for 47 and 76 gig arrangements. There's just a few more here now. 100 years ago, the discovery of the ionosphere. So this is a bit of a historical article. The next one that I wanted to focus in on is here we go. So Miguel Pelicano, who is CT1BYM. This is moon bounce communication on 47 gigs. So this is taking it to the next level. The transmission was carried out with a 2.4 meter antenna and 40 watts of power. I suspect probably a travelling wave tube. No. It's a solid state power amplifier, SSPA. So there you go, and producing 40 watts at 47 gigs. You can see this is the feed for the dish. Water cooled SSPA. So this is giving the 40 watts using water cooling. Wow. Okay. The complete setup with water cooling and DC control. And it talks about, on this particular page, my first 47 gig EME QSO, which was with Mitsuo, so a Japanese JA1WQF, Sergei, who is Russian, RW3BP, and Manfred DL7YC, took the opportunity to test the system in transmission for the first time, and so on the morning of May the 27th, with the moon still relatively low in the sky, about 20 degrees elevation, I completed my first 47 gig QSO, moon bounce QSO. The contact lasted 7 minutes and was completed at 0740 UTC. Well, there you go, 47 gig. Now, Earth, Moon, Earth. In the millimetre range, a historic perspective. So it talks about the history of all the way through from 270 all the way through the EME conferences that occur each couple of years. In the 17th EME contest 2016 in Venice, an idea was born, and the 47 gig all the way up to EME at 47 gigs. Fantastic. The travelling wave tube and the power supply, the high voltage power supply, scary high voltage power supply, the 11 watt 47 gig SSPA, so the solid state used by the Japanese amateur who made that contact. You can see they're all joined together in parallel to give the 11 watts. Absolutely fantastic. And then the last article that I just wanted to point out here, experiments on moon bounce at 47 gig. There was, here we go, by Ivan De Serres, who is IZ0JNY, so Italian amateur, talks about his experiments of 24 gig system for EME activity. And there's a picture of his 24 gig system. He uses a travelling wave tube, delivers around 19 watts from 150 watts input. So 19 watts at 24 gigs, doing pretty well. And then how he put it together and all the tests that he did. 24 gigs is an interesting band because it is fraught with difficulty because 24 gigs is right in the band that we use is right between two water peaks. And water at 24 gigs is a fantastic attenuator. So you if there is any moisture, you're looking at humidity in the air. If there's any sort of moisture, any sort of clouds or that sort of thing, you can find that there's significant attenuation. So, now Lisa, and we've got Colin from VK. Hello. Very interesting. I've gotten hold of an old satellite dish to repurpose it for the hydrogen line. Fantastic. Well, we look forward to getting you on, Lisa, and you can take us on your journey. So, how are we going for time? Okay. All right. Doing okay. Now, the next article that I want to go through is I actually came across this particular article in Silicon Chip of September 2008. Now, Basslink's a bit of old news in Tasmania. This is a high voltage DC cable between Tasmania and the mainland. But the interesting thing in here, which I thought was worth going through in a little bit of detail, is the technology that they actually use to do the DC to AC and the AC to DC switching. And it's absolutely fascinating. So I'll just go through some of the stats so that you've got an idea. So just to start off with, so what we've got is Basslink is a 370 kilometre length of high voltage DC cable that includes 290 kilometres that are actually under the sea, so under Bass Strait. So 290 of the 370 is actually under the sea. Now, that's one of the unique things about Basslink, because high voltage DC cables are not an unusual thing. There are many in Japan, there are many in Europe, but most of them do not go through a water path. So that was one of the unique things with Basslink. It connects at the Tasmanian end. It is 220,000 volts. So the AC voltage that goes into the converter station at Georgetown is at 220 kV. At the Victorian end, it is at Loy Yang, and I'll show a picture of that. That's at Loy Yang, and it then feeds, the DC converts to AC, and it feeds into the 500 kilovolts, so the 500,000 volt, or half a megavolt, the 500,000 volt Victorian transmission system at Loy Yang substation. So it goes in at Tasmania at 220, comes out Victoria at 500 kV. Now, it is high voltage DC, so it converts to 400 kilovolts, 400,000 volts DC, and it's rated at a current of a maximum of 1250 amps. The reason they do that, this is all about Ohm's law, because if you raise the voltage and drop the current, you obviously lessen the resistive losses. That's why they have high voltage AC cables across the countryside. Go up to high voltage, lower the current, you don't have the losses, the resistive losses. Why do they go to all this trouble of converting it to DC and then back to AC? Why don't they just run AC across a Bass Strait? Well, the simple thing, if you think about it, a DC cable is a high voltage DC cable to transfer the DC, and an earth return, so that's two cables. If you were to run AC, so three-phase AC, you would need at least 3 cables. So that's at least 3 times, less than 3 times the cost, but almost. So if you want to connect, the other advantage of doing this conversion to DC and back to AC is if you have, and this is very relevant in Japan. Japan, as a country, runs both. They have 60 hertz systems, AC systems, and 50 hertz systems. When you do the conversion at these converter stations, and I'll go through how they do that in a sec, when you do this conversion, it can be any frequency at each end that you convert back to. And so you could be connecting a 60 hertz system to a 50 hertz system, doesn't matter at all. You just recreate that frequency, that AC frequency at the end, and sync it to that particular grid. That's the other advantage. Given you are converting it to DC, you don't have reactive losses, so inductive or capacitive losses, or you have much less having to compensate for those particular losses. So that's the other advantage, and you can control and monitor the direction of flow. So and I'll go into how they do that in a short while. There's a fascinating way that they do that. So you can have and you hear the National Energy Market, the NEM, talk about shipping power to the mainland or buying it back at cheap rates or shipping it over when it's at expensive rates, or and Tasmania benefits from that and all sorts of things. So it gives them the ability to control that bidirectionality. So it's rated at 500 megawatts at running at that 400 kilovolts at 1250 amps. They also talk about, it's interesting, they talk about an overload capacity. Now this got a lot of this got a lot of airplay when Basslink failed, because there were things flying around that Basslink had cooked the cable and all sorts of stuff. But there is an overload capacity on the transmission system, so you can run it up to 630 megawatts for up to 8 hours a day. However, you have to then let the cable cool down. And that's one of the advantages running it under the sea. You do have the ability to, obviously that heat gets dissipated in the sediments in the where the cable's laid in Bass Strait. But the key thing there, and you need to let the cable cool down, and this was the subject of a very protracted court case. I've got a note here between the Tasmanian government and Basslink when the cable failed. And all sorts of things. But now, okay, at the each end, here we go. So this is the Loy Yang end of Basslink, and you can see this is all Siemens solid state switching equipment, and I'll go into this in a minute. You can see there are 3 for each phase. There are banks of thyristors, and I'll go into those thyristors. They are fascinating, absolutely fascinating devices. We know what thyristors are, but how they're actually triggered is absolutely fascinating. And you can see we are talking 400,000 volts. Well, we're talking 400,000 volts DC at this point, but we're also talking about 500,000 volts AC when it feeds into the Victorian system. So you can see this is in the what they call the DC valve hole. So the valve meaning they can switch it on and off. In Victoria's Gippsland. These racks of thyristors hang from the ceiling, and they hang to protect them from damage in case of earthquake. So they're actually sprung off from the ceiling, and they've got an ability to a certain amount of movement. And you can see lots of discharge. Everything's circular. There's no square corners on this. So that the corona discharge doesn't focus on particular points. But the interesting thing here is these are made up of banks of what they call light triggered thyristors. So we know what a thyristor is. A thyristor is, you can switch AC through a thyristor, and when it gets to a certain part of the AC cycle, you can get the thyristor to switch on and then switch off based on the current going through the device. But the difference here is these are the thyristors that they use to switch the DC to AC or vice versa, and I'll go into that in a sec. These are about 125 millimeters in diameter to give you an idea of their size. Oh, pardon. So these they're about 125 millimeters in diameter. They are capable of switching of a blocking voltage of about 8,000 volts, and they can handle 4,000 amps of current. And the interesting thing is they are triggered by light. So what they do is they have a fibre optic into the substrate of the thyristor, here that yellow part of the thyristor, and they trigger the thyristor by putting 10 milliwatts of laser light down those light pipes. Now if you think about it, you've got potentially 8,000 volts at 4,000 amps, scary amounts of voltage and scary amounts of current sitting in this pancake. And so you have a fibre optic that feeds into the centre of this, which triggers these thyristors. So you can have the isolation between the control circuit and the actual high voltage side of these thyristors. Now, if I just turn over the page, there is a great diagram. Here we go. There is a great diagram. This is the simplified version. And we'll go through. And this is, so what we've got here is a three-phase transformer in star configuration. So it can either be star or it can be delta. This is delta configuration, where each of those windings are connected together and each phase comes off those ends, whereas versus the star configuration where they're joined in the middle and each phase comes off the end. So we've got the three-phase coming in here from either Victoria or Tasmania, goes through a transformer. This is in star, and you've got a very simplified here, 6 thyristors, which then are switched, and I'll go into the switching in a sec, are switched to a DC output. So this is the high voltage DC cable side. This is the AC side of the circuit. Now, what they do is these 6 SCRs are switched two at a time to effectively, and this is going from, if you've got AC coming in here and we want DC to come out here, these effectively are like a bridge rectifier. This is a good example of a bridge rectifier here, but they are selectively switched on in the pairs to give you a DC voltage. So every time, here's your 3-phase coming out of your transformer, and they are switched for 60%, about 60% of the 360 degree cycle, or 60% of the 90 degree at the top, and they switch those thyristors on for that 60% to effectively give you a very ripply, or a 300 hertz ripple DC output at this 400 volts DC. So you can see it's grabbing the positive side of each phase and outputting it out on the DC cable. And so the right pair of these in the right switching sequence gives you, and the switching sequence is based on the frequency of what's coming in. In this case, it'll be 50 hertz. Well, it's 50 hertz in both sides, but it could be 60 hertz, could be 100 hertz, could be whatever. So that's how they go from AC to DC. If we then want to go from DC coming in to AC coming out, what we've got is, and this is closer to what is actually in those big racks that I showed you. What we've got is effectively 12 of the thyristors in combination, and it is switched. So for the star arrangement, what you can see is the simplified version of this is if you want to go from AC to DC, it goes through that star arrangement, and these pairs are switched to give you DC. If you want to go from DC, so you've got DC coming in and you want to switch them to AC and actually recreate the AC waveform in 3 phase, so 120 degrees out of phase, times 3, etc. You've got the combination of all 12 being switched to give you the 3 phase output, which is, you can see here's 1 phase, 2 phase, 3 phase, and they're 120 degrees out of phase, so 360 for the whole lot. And you end up with effectively 600 hertz of ripple because it's taking each one of these slightly out of phase to generate the full 3-phase AC output at 500 kV at the Loy Yang end, or 220 at the Tasmanian end, at the Georgetown end. So if you put it all together in a simplified form, you've got effectively, we'll say this is Tasmania. This is the Tasmanian grid, goes into this special transformer with the star and delta arrangement and the switching valves. And there's 3 banks of them on each side. And you can see the AC, the DC coming into AC comes through this delta arrangement and out. In the reverse direction, it goes through the star arrangement and comes out. So AC creates the DC across the cable, across Bass Strait, back in here, through the star arrangement, and then converted back out to AC. And vice versa in the other direction. Now, have I missed anything? So the 6 pulses are required to recreate a sine wave, and the trigger sequence is obviously really important to recreate that AC wave. Now, in creating that, one of the problems they have is and you think about it. This is exactly RF at a much lower frequency, but it is still alternating current. It creates a whole lot of effectively artifacts and harmonics if you don't get that switching sequence right. And so there is an amount of filtering that goes on in here. Each side of the Bass Strait to clean up that waveform and make it vaguely like a sine wave. It's never a perfect sine wave, but there is a whole lot of filtering that enables it to look as close to a sine wave as they can get it. But now that arrangement with the thyristors is all water cooled because those thyristors get quite warm apparently. So there is water cooling in these racks that creates a whole series of other challenges. So these banks of thyristors, each phase that we're talking about here, there is water cooling throughout those banks of thyristors. Simplified bidirectionals. Now, the other thing they want to avoid here too is fire. All the materials that are used throughout these racks are all fire retardant, and they're made with self-extinguishing plastics. So if there is anything that gets too hot, it cannot catch fire. There is no so in these sort of arrangements and in big transformers, they use oil for cooling. There is no oil used throughout this. Anything that can potentially catch fire. they've replaced the oil with sulfur hexafluorine, so SF6. SF6 is a gas. It is a gas that has incredible insulating properties, and so they anywhere where they need insulation, they create a gas-filled void around so that it creates that insulation, and they pump and keep at a particular pressure the sulfur hexafluorine gas. Quite dangerous gas, but it has its fantastic properties. Now, the one thing I haven't shown you is where does it go across Bass Strait? Now, hang on. The control system doing the switching must be amazing. Yeah, Darren, yes. It is effectively taking DC and recreating AC in 3 phases on the Tasmanian end 220 volts at scary currents, and on the Victorian end 500 kV at scary currents as well. So you can see here it goes from Georgetown, the Georgetown converter station. It goes up through Low Head to 4 Mile Bluff, then goes offshore. It goes across, it goes past Deal Island, goes past the Hogan Group, and the Curtis Group, goes up here, Hogan Group here, does a bit of a bend here and goes across to McGarren's Beach, and then into Loyang, which is somewhere just up here, and then into the now what you're almost into the Latrobe Valley here, which is where is power generation central in Victoria. So it's where all their old coal-fired power stations are. And so there is the distribution grids all leave from this area, so it's a logical place to inject into the grid there. So that's where it goes across Bass Strait. Here we go. What does the cable look like? Okay, so this is it's Prysmian cable. This is the high voltage cable. You can see this is, I don't actually know what this insulating material is, but I suspect it's something like XLPE. It's what they use. It's a special type of plastic which has fantastic insulating properties, but that's the insulating properties. This is all solid copper in here. Now, it is DC, and so you don't have a surface effect, which you have with AC, and so it uses all of that copper, and so the 1250 amps that you can run through this, it is actually using all of that copper. This is the earth return. The earth return obviously is slightly bigger. You can see it has some armouring around it, but much lower insulating properties, because this is at earth potential. So you don't need this sort of insulation in the cable. And then the third one here, this is the fibre. So there are 12 fibre optic cables in the centre of that. There's lots of armouring around that to protect the 12 optical fibres in that cable. And that's laid as a package. So you can see down here, this is how it is actually laid. It's got a wrap around it, polypropylene rope around it, and they are wrapped together. You can see the copper conductor. It just says insulation here. I suspect it's something like XLPE insulation. There is insulation screen. There's a lead alloy sheath. There is polyethylene sheath. There is armouring bedding. Then there's armouring around here, which is steel cables. And then there's string serving around the outside. Then there's a plastic coating around the outside of that. Copper conductor, insulation screen, very similar, but obviously much less insulation. So now, I said to Matt just before we came on, Joe Gelston, who is sadly silent key, actually had a cross section, had a section of these two cables that he showed at Meet the Voice event many years ago. just after Basslink had been put in. And I took a photo. I took a couple of photos of these cross sections, and do you think I can find the photo? Anyway, that's Basslink. Any questions? Please drop them in the chat. Now we're over time, so I'll very quickly. Australian Space Weather Report. Nothing of any significance at this point in time, other than crap VHF conditions, which is what Matt outlined. So there's nothing of any note at the moment. We have a standard advanced and regulations assessment day on Saturday. We also have many of us are at the state championships for the equine endurance event up at Sassafras on the weekend. So there are lots of people all going up to Sassafras out into the bush and talking to people going past on horses and numbers and all sorts of stuff. So you'll hear a lot of activity coming from Sassafras over the weekend. But there's also a standard advanced and regulations assessment day. That's our last one for this year. The first foundation assessment day in 2026 is the 21st of February. Now, reminder, next week is our end of year barbecue. Our end of year barbecue, which is, it will be two barbecues actually. One at lunchtime for our Wednesday afternoon group, and one for our Wednesday experimenters group, Wednesday evening group up here. We won't have any stream. We won't stream us eating snags and whatever else. So you can you can be thankful for that. But that's next week. Have a sizzle. Yeah. Oh, there. Andy is on. Hello, Andy. we were missing you. We were missing you earlier. And so our first event for January 2026 is on the 18th. Which is a huge Carboot sale up here on the Sunday. It's on the 18th is a Sunday after the broadcast, and we have a sausage sizzle up here as well. So that's the last event for 2025. We will have our Wednesday experimenters group throughout December. So we will have shows in the in the studio up until the end of the year. And then into January, so you can come on. We'll have a special Christmas one as well. We might even dress up as Father Christmas or something, and give everybody the radio of their dreams. Hi. Maybe. Anyway, that's your blooming lot for this week. This has been VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our Wednesday experimenters group. Hope you've enjoyed it, and a huge thank you to Matt, VK7 MAT, for sharing his field day experience. Until now, fortnight's time. We will catch you then. 73, everyone, and have a great week, and we'll see you in a fortnight's time.